Hello, and welcome to this look at a challenging redox titration question, where there's several things going on. Firstly, you have to find the number of moles of water of crystallization. You then have to also work out the identity of an unknown metal in a double salt. So a double salt contains two cations and one anion. And it's also using a thiosulfate copper redox reaction, which means there's two equations that happen in sequence. So the question tells you the formula of the double salt and that M is an unknown metal ion which doesn't react with iodide or thiosulfate. So that must mean only copper will react with those two things. So the titration was carried out and it tells you three sentences that describe how that's set up. So you take 0.5 grams of your double salt, you dissolve it in 100 centimeters cubed of water, and you titrate it using sodium thiosulfate at 3 times 10 to the minus 3 moles per decimeter cubed. And then you react that with some iodine. 10 centimeters cubed to be exact, because it says excess iodide ions were added to 10 centimeters cubed portions of this solution, forming a white precipitate and a brown solution of iodine. So the mean titer was 21.60 centimeters cubed. And from the two equations, you can see it's a 1-to-1 mole ratio in its simplest form between copper 2+ and thiosulfate. So let's clear some space to do this calculation. There's two parts to part A. So part A, part 1, and part A, part 2 can both be covered by the data moles equation moles answer technique. So you take the volume and the concentration of your thiosulfate and you multiply them together, obviously changing the 21.60 into decimeters cubed by dividing by 1,000, and that gives you 6.48 times 10 to the minus 5. From the equation, as we saw, there's a 1-to-1 mole ratio between the two ions, S2O3 2- and Cu2+. So that gives us 6.48 times 10 to the minus 5 moles in our 10 centimeters cubed portions, which came from 100 centimeters cubed. So multiplying that up by 10 gives you 6.48 times 10 to the minus 4. So if you multiply that by the molar mass of copper, that gives us 4.1148 times 10 to the minus 2, which to two significant figures. There we go, to two significant figures is 4.1 times 10 to the minus 2. So the next thing to do is to have a look at the final part. So if we take a closer look at the formula, we need to work out the moles of water of crystallization. So it tells us that the remaining mass of all the water had been driven off was 0.430 grams. You started with 0.5 grams. So the difference must be the mass of water that was driven off. So dividing the mass of water driven off by its molar mass, you get 0.00389. Now let's handle the anhydrous salt. Now, we don't know what M is yet, but we know that there's one copper for every one of these whole things here. So only one copper within that whole salt. So we can also assume that the number of moles of copper is the same as the number of moles of our double salt. So therefore that's 6.48 times 10 to the minus 4. So if we take the equation again and put our ratio down and divide by the smallest, we get 1 to 6. So that now means that the value for N must be 6. So we can write that instead. Okay, so now we need to work out what the molar mass of what we know is. So adding it all up, not counting M2, is 363.7 grams per mole. So the molar mass of the anhydrous M2CuSO4, ignoring the water for now, is the remaining mass divided by the moles of the salt, which is going to be 0.000648. That's your 6.48 times 10 to the minus 4. Okay, so now let's look at the whole thing. If it's 663 grams per mole, or 663.5802 46913 if you keep your calculator value, that's just this part. The whole thing is going to be that plus 6 times 18 added on. So we're now coming back to the fact you've got 6 moles of water. and adding those onto the 663.580246.913. And then you get 771.580246913. So this is the whole thing. So the molar mass not counting M2 is 363.7. So subtract that away from 771.58 blah blah blah, and you get 407.8802469. But that's 2 M's because it says 2. So divide that by 2, and that must give you 203.940123 grams per mole. And looking at the periodic table, thallium is the closest to that value. So our formula for double salt must be Tl2Cu SO42 6H2O. Okay, so I hope that made sense. Quite a lot going on there, but thanks for making it to the end. Until next time, thanks for listening, and see you soon.